ఇదేనమ్మా మీరు అడిగే ప్రాబ్లం నెంబర్ 3. హలో
ఏ పొటెన్షియల్ కంట్రోల్ సిస్టమ్ లో ఉంటారు.
అదే స్క్రీన్ కనబడుతుందా షేర్ చేసింది?
కనిపిస్తుంది సార్. అదే సార్
మీ దగ్గర ప్రాబ్లము మీరు అడిగేది?
ఎస్ సార్.
ఓకే ఓకే అమ్మా. So the problem number 3 is a positional control system with velocity feedback is shown in figure. What is the response of the system for unit step input? So that means మీకు ఒక సిస్టమ్ ఇచ్చాడు, ఆ సిస్టమ్ కి రెస్పాన్స్ ఏంటి అనేది ఫైండ్ అవుట్ చేయమంటున్నాడు ఫర్ ద యూనిట్ స్టెప్ ఇన్పుట్. ఓకే, సో ఫర్ దిస్ కేస్ what is your corresponding solution? Okay, so what is the figure we are going to given? Hundred by S into S plus 2 by feedback ఏంటి ఇక్కడ?
0.1 S plus 1.
0.1 S plus 1. Okay, so C of S R of S. ఇదేనా మీకు ఇచ్చిన ప్రాబ్లం?
Yes sir.
Okay, so that means what is the response of the system for unit step input? That means we want to go on to find out what is the value of C of t when the input is the unit step input. That means what is the value of R of S? R of S value is
1
equal
by S, sir.
by S.
1 by
Okay, so for this case we are going to consider it is a second order closed loop system. So that means what we are going to observe, C of S by R of S is equal to G of S by 1 plus G of S into H of S. Here this block should be called as a G of S and this one should be called as my H of S. That is nothing but the G of S is a forward part function block and H of S should be called as a feedback part function block. So the given system should be called as a second order closed loop system. Therefore from this we are going to say that the value of C of S by R of S, the value of C of S by R of S, that is nothing but G of S by 1 plus G of S into H of S. So now we are going to substitute in the value of G of S, that is 100 by S into S plus 2 divided by 1 plus 100 by S into S plus 2 into H of S value is 0.1 into S plus 1. Okay, so now we are going to simplify this one and get what is the value of C of S by R of S. That is
100 by S into
ఎంత వచ్చిందమ్మా మీకు ఫైనల్ గా?
100 by S into S plus 2 plus 100 into 0.S plus 1.
100 by S into
S plus 2
S plus 2
plus 100 into 0.1 S plus 1.
plus 100 into 0.1 S plus
0.
అంతేనా?
అంత వచ్చింది సార్.
దీన్ని సింప్లిఫై చేస్తే ఏమొస్తుంది మీకు? 100 by
S square plus 2S plus
2s 12s
12s plus 100 sir.
12s plus 100.
Yes, sir.
So the CFS by R of S value is equal to 100 by S square plus 12s plus 100. So in this case, the denominator value is nothing but call it as your characteristic equation, or we are going to call it as my characteristic phenomenon. So what is your denominator which we are going to consider? That should be called as a S square plus 12s plus 100. That should be called as my characteristic value. So in order we want to find out the response of your system. For that, generally what we are going to observe, we are going to get C of S by R of S equal to something value we get. After we are going to apply the partial expansion method, that is A by some B by some C by some D by and so on. After we are going to solving the different values, and finally we get what is the value of C of S by R of S, and then we are going to apply the transformation. We get the what is the value of C of T. So now we want to going to consider to see that the denominator is not able to directly to consider as the partial expansion. For that we want to going to bring out the particular C of S by R of S into the form of partial expansion, and then we want to going to be able to solve the values. That value should be substituted in your C of S by R of S, and then we are going to apply the Laplace transform, inverse Laplace, and we get the value of response, that is C of T. So now we want to going to find out what is the roots of your characteristic equation. The roots of your characteristic phenomenal, or what are the roots that we are going to consider? Let us, we are going to say that is S equal to minus B, that is 12 plus or minus root of B square minus 4AC. B square minus 4AC divided by 2A. Okay. So minus B plus or minus root of B square minus 4AC by 2A. That should be equal to minus 12 plus or minus root of, so 12 square is nothing but 144 minus 400 divided by 2. That is nothing but we get, that is minus 12 plus or minus j into 16 by 2. So what is the value we get? That should be equal to minus 6 plus or minus j into 8. Okay. So in this concept case, after we are going to apply the value of roots of your characteristic equation, minus b plus or minus root of b squared minus 4ac, that is minus 12 plus or minus root of minus 256. So the root of minus 256 is 16. We get, that is minus 12 plus or minus j 16 by 2. We get, that is minus 6 plus or minus j into 8. So in this concept case, we are going to saying that what are the roots which we are going to consider? The roots are complex conjugate. What are the roots which we are going to call it as the roots of complex conjugate? So whenever the roots are complex conjugate, we are going to saying that the system should be called as the underdamped system. That is the 0 less than zeta less than 1. And the response should be having called as a damped oscillation depending on value of zeta. Okay. So this is nothing but called as a what is the value of S. So for this case, what is the value of C of S that we are going to mainly get? So now we are going to consider that is C of S by R of S value ఎంత వచ్చిందేమో మనకి 100 by S square plus 12s plus 100. అదేనా మీకు వచ్చిన వాల్యూ?
Yes, sir.
So now we are going to consider it is a response which I am going to consider in my S domain. Therefore, I am going to written that is C of S is equal to R of S into 100 by S square plus 12s plus 100. So now I am going to substituting the value of R of S value is the 1 by S. Therefore, we get that is C of S is equal to R of S value is nothing but 1 by S into 100 by S square plus 12s plus 100. That should be mainly equal to 100 by S into S square plus 12s plus 100. That means for the review of your partial fraction of your expansion, for this case the roots should be having called as a complex conjugate roots in your denominator. So therefore we are going to consider to get that is by partial fraction expansion, what we are going to get that is C of S is equal to A by S plus BS plus C by S square plus 12s plus 100. Okay. What is the value of C of S equal to A by S plus BS plus C by S square plus 12s plus 100. So now we want to go into solving the values of A, B and C. That value should be the mainly substituted in this particular C of S and then apply the inverse Laplace transform of C of S. There we get what is the value of C of T. We want to go into solving the value of A, B and C. That is A equal to S into C of S at S equal to 0. That means the value of S into C of S value is nothing but 100 by S into S square plus 12s plus 100. When we are going to apply that S equal to 0, this one is cancelled. That is A equal to 100 by 100. Then we get the value of 1. Okay. So there we get what is the value of 1. So now we want to go to consider to finding out the value of B and C. So that means in order we want to go to finding the value of B and C, we want to go to equating the power of S and S square, and then we are going to solve to finding out the value of B and C. That is What is the value? That is C of S is equal to S into S square plus 12s plus 100, that equal to A by S plus Bs plus C by S square plus 12s plus 100. So now we are going to equating the value, that is 100 equal to A into S square plus 12s plus 100 plus S into Bs plus C. So where simplify value, that is A into S square plus 12 into AS plus 100 into A plus B into S square plus C into S. Now on equating the coefficient of coefficients of power of S square, we get, that is 0 is equal to A plus B. Then what is the value of A? A equal to 1. That equal to 1 plus B. From this we get what is the value of B equal to minus 1. Okay. So now I want to go to equating the coefficient of power of S. We get, that is 0 is equal to 12A plus C, where A equal to 1 plus C. From this we get what is the value of C equal to minus 12. Therefore, we get the value of A and B, that is A equal to 1, B equal to minus 1, C equal to minus 12. So now we are going to substitute in your C of S, that is C of S is equal to A by S, 1 by S plus Bs plus C, that is Bs plus C by S square plus 12s plus 100. So that is value we are going to simplify, that is 1s plus, minus s minus 12 got the minus of s plus 12 divided by s square plus 12s plus 100. Okay. So now when we are going to apply, the inverse Laplace of C of S, for this one that should not be the mainly possible. So now we want to bring out this particular value by simplify this equation, that is C of S is equal to 1 by S minus S plus ఈ 12 నేను 6 plus 6 కింద రాసుకుంటున్నాను అమ్మా, divided by, so what is the form, that is A square plus B square plus 2AB. So here we want to get what is the value of 2AB. A value anta 1, B value 6.
12.
Okay. So that means the value we want to consider to make this one in the form of A plus B whole square. So if I are going to write down this in the denominator as some s
S
plus
plus 6.
6 whole square plus 64. అంటే ఏంటి ఇక్కడ ఈ 100 ని 36 plus 64 కింద split చేసుకుంటున్నానమ్మా. Okay, so that means I am going to get what is the value of, that is we are going to call it as a what a plus b whole square. A plus b whole square is a square plus b square plus 2ab. So ఈ యొక్క particular case of b value 6. So that means b value is equal to 6 and a value equal to 1. ఇక స్ప్లిట్ చేస్తే నాకు ఇక్కడ సరిపోయినా నాకు ఇక్కడ సేమ్ అవుతుంది. నాకు ఇక్కడ a value is 1, that is a square s square plus b value is 36. So b square is 36 plus 64, that is equal to 100, and 2ab, that is the 2 into 1 into 6, that is 12. We get what is the value. So this one that we are going to consider, which I am going to mainly split up, the 12 should be mainly splitting into 6 plus 6, and this particular value of 100 that I am going to mainly split up into 36 plus 64. From this I am going to consider that as a plus b whole square plus 64, what we are going to get. So now we are going to split up this particular value. Okay, now I am going to mainly split up this particular value, that is C of s is equal to 1 by s minus s plus 6 by x plus 6 whole square plus 64 minus 6 by x plus 6 whole square plus 64. So now I want to go to apply this particular one. Direct ga నాకు ఏమన్నా వస్తారా ఇక్కడ? If I am going to apply the inverse Laplace of transform of this particular C of s, 1 by s ki directly we get value of 1, x plus 6 by s plus 6 whole square plus 64. That value we are going to get, that is the e power minus 80 into cos 80. What about quadratic my total? That is a 6 by x plus 6 whole square plus 64. That means directly I should not be the mainly get. If I want to get the value, that is something a by s plus a whole square plus b square ganaka unte naku we get, that is a e power 60 into sin 80. So therefore ఒకసారి ఇన్వర్స్ లాప్లాస్ ట్రాన్స్ఫార్మ్ లో cos 80 కి sin 80 కి ఫార్ములా ఏంటో చూసుకున్నామా. That is, for that case I am going to consider, that is 1 by s minus x plus 6 by x plus 6 whole square plus 64 minus, ఇక్కడ నేను ఏం చేస్తాను అంటే multiply and divide by a, which I want to get, that is x plus 6 whole square plus 8 square. That we are going to call it as sin a into t. We are going to multiply and divide by 8, and from this we are going to get to form the sin 80 into sin 80 form loki cos 80 form loki తీసుకొస్తున్నాను. So finally, if I am going to apply the inverse Laplace transform of C of s, ఇక్కడ కూడా I am going to bring out this particular form as cos 80. We get the 64 square ni 64 ni I am going to consider as a 8 square. So we are going to consider the same term, multiply and divide by 8. So now we are going to apply the inverse Laplace transform of C of S. There we get that is C of t is equal to 1 minus e power minus 16 to t into cos 8t minus 6 by 8 into e power minus 16 to 2 into sin 8t. Okay, so that is a case which we are going to consider what we are going to mainly observe. So from this, if you want to go to again simplify by taking the common as 1 minus e power minus 16 to t can common తీస్తే we get the term that is ఏమొస్తుందమ్మా e power minus 16 to t common తీస్తే that is
cos 80
cos 80 ఇక్కడ ప్లస్ మైనస్
minus 6 by 8 plus
ప్లస్
6 by 8 sin 80t.
sin 80. Okay, so this we are going to consider what is the response of your system for the given system. Okay, now so ఏమీ లేదు, మీకు వచ్చిన పార్షియల్ ఫ్రాక్షన్ చేసిన తర్వాత డైరెక్ట్ గా మీ లాప్లాస్ ట్రాన్స్ఫార్మ్ అప్లై చేస్తే ఇన్వర్స్ లాప్లాస్ ట్రాన్స్ఫార్మ్ అప్లై చేస్తే డైరెక్ట్ గా కాసుల్లో కానీ సైన్లో కానీ వస్తుందో లేదో చెక్ చేసుకోండి. ఇన్ కేస్ రాకపోతే కాస్ 80లో కానీ సైన్ 80లో కానీ వచ్చేటట్టు ప్లాన్ చేసుకొని ఏ టర్మ్ యాడ్ చేయాలి, ఏ టర్మ్ సబ్ట్రాక్ట్ చేయాలి, ఏ టర్మ్తో మల్టిప్లై చేయాలి, ఏ టర్మ్తో డివైడ్ చేయాలి అనేది చూసుకుంటే we get what is the response which we are going to mainly takes place. Okay, now so this is the solution which we are going to consider for your third problem. Okay, now ఇంకేమైనా డౌట్ ఉన్నాయమ్మా మీకు? ఏ ప్రాబ్లం అయినా డౌట్ ఉందా? ఇంకోటి ఇదమ్మా
8th one sir, 8th one.
8th one ఇదేనా?
అదే సార్.
A unity feedback control system is characterized by the following open loop transfer function. G of s is equal to 0.4 into s plus 1 divided by 8 s into s plus 6. Determine its transient response for unit step input and sketch the response. Evaluate the maximum overshoot and the corresponding peak time. So same pine chasing problem lage kada adi kuda so ఇది కూడా అదే ప్రొసెసర్ తో వస్తారమ్మా మీకు. ఓకే, లెట్ us try. ప్రాబ్లం నెంబర్ 8. Okay, you are going to consider the solution for your problem number 8. ఏమి ఇచ్చాడు? A unity feedback control system, that is HFS value is equal to 1, is characterized by the following open loop transform G of s. G of s is equal to 0.4 into s plus 1 by s into s plus 0.6. Determine its transient response for the unit step input. So we want to go to find out of what is your transient response in your time domain. So the transient response. So what is the total response we get? Okay, I will tell. We want to find out the transient's response. And you can find out chemanadu. Evaluate the maximum overshoot. That is, we want to finding out the value of maximum overshoot and the corresponding peak time. So what is the value of your peak time that we want to mainly find out? Okay. So let us, we are going to start with the help of same procedure, that is, we want to write down what is your closed loop transfer function. C of s by R of s is equal to G of s by 1 plus G of s into H of s. The G of s value is nothing but 0.4 into s divided plus 1 by s into s plus 0.6 divided by 1 plus 0.4 into s plus 1 by s into s plus 0.6 into h of s value is the 1. So now we are going to simplify this particular one. So now we are going to be able to simplify this particular one, and finally we get that is C of s by R of s is equal to, simplify చేస్తే ఏమొస్తుందో మీకు 0.4 into s plus 1 by
s square plus s plus 1, sir.
S square plus s plus 1. So again, this is the closed loop transfer function. What we get, that is C of s by R of s value. In this case also, we are going to consider the response which has going to taken in your S domain. That is, C of s is equal to R of s into transfer function, that is 0.4 s plus 1 by s square plus s plus 1. So here also we get the input should be called as the unit step input. Therefore, the value of R of s should be called is equal to 1 by s. Okay. So now we are going to write down the value, that is C of s equal to 1 by s into 0.4 into s plus 1 by s square plus s plus 1. That should be equal to 0.4 s plus 1 by s into s square plus s plus 1. So now we are going to apply the partial fraction expansion. Now we are going to apply the partial fraction expansion. So then we get, that is C of s is equal to a by s plus bs plus c by s square plus s plus 1. Same indaka problem lage, we want to go to able to solving the value of a, b and c. That value we are going to substitute it in this particular equation, and finally we want to get applying the inverse Laplace, and we want to go to find out the first response of your system. Elagostal values, that is a value a equal to s into c of s at s equal to 0. So what is the value of c of s? C of s equal to 0.4 s plus 1 by s into s square plus s plus 1. So yes cancel just then, that is 1 by 1, that equal to 1. Okay now? So now again we want to go to finding out the value of B and C. So C of S value, that is 0.4s plus 1, that is S into S square plus 1 is equal to A by S plus BS plus C by S square plus S plus 1. So that is 0.4s plus 1 is equal to A into S square plus S plus 1 plus S into BS plus C. That equal to A into S square plus AS plus A plus BS square plus C into S. That is nothing but 0.4s plus 1. So now we are going to equating the power of S square, and as we get so there we are going to equating the power of S square, we get that is 0 equal to A plus B. A value is 1. From this we get that is a B equal to minus 1. Okay. So now we are going to equating the power of S. There we get that is 0.4 is equal to A plus C. 0.4 equal to 1 plus C. From this we get what is the value of C is equal to minus 0.6. Okay. So therefore okay, therefore A value is 1, B value is minus 1 and C value equal to minus 0.6. Now we are going to substitute in your C of S, that is C of S is equal to A by S plus B by BS plus C. BS plus C by S square plus S plus 1. That should be equal to 1 by S minus S plus 0.6 by S square plus S plus 1. So ikkada what we are going to mainly observe. So from this what we are going to mainly observe, in order we want to go to finding out the value of C of t, first I want to go to find out. So in this case, for the sake of my simplification, I am going to write down this. So for the sake of my simplification, I am going to write down this, that is this particular 0.6. I am going to write down this as 0.5 plus 0.1. If I am going to write down as 0.6 plus 0.1, and whereas for case of my 1, what is the value which I am going to consider? That I am going to write down as 0.75 plus 0.25. Okay. So now I am going to write down this as, that is CFS equal to 1 by S minus s plus 0.5 by s plus 0.5 by ఇక్కడ టోటల్ గా వచ్చే వాల్యూ a plus b హోల్ స్క్వేర్ ఇందాకలాగా చేసుకుంటే s plus 0.5 whole square plus 0.75. So that is what is the term which we are going to consider, that we are going to mainly return. So from this which you are going to return as so from this which you are going to mainly return as s plus 0.5 by s square plus s plus 1 as a plus b whole square ఆ ఫామ్ లో కనుక రాసుకొని ఆ 1 ని నేను స్ప్లిట్ చేసుకున్నాను 0.75 plus 0.25 కానీ స్ప్లిట్ చేసుకుంటే అక్కడ I am going to get what is the value of b is equal to 0.25. దాన్ని I am going to mainly return. So likewise I am going to consider what is the value, that is 0.1, that is 0.15. I am going to consider to make down the multiply and divide by some root of 0.75 to multiply divide cheste, that is I am going to consider that is s plus 0.5 whole square plus 0.75. So ఇక్కడ మిగిలిపోయిన 0.1 ని నేను ఇలా రాసుకున్నాను multiply and divide by root of 0.75. So now I am going to consider applying the inverse Laplace transform. Now I am going to apply the inverse Laplace transform of C of S. Then what I am going to get is, that is C of t equal to 1 minus C of t equal to 1 minus e power minus 0.5 into t cos root of 0.75 into t minus 0.1 by root of 0.75 e power minus 0.5 into t into sine root of 0.75 into t. So that is the thing which we are going to consider, what I am going to make it taken and why I am going to splitting this particular value. Okay, Nishama. Yeah. Okay. After we are going to splitting the value of 1 as 0.75 plus 25 and 0.6 as 0.5 plus 0.1. So there we get, after applying the inverse Laplace transform of C of S, there we get. So from this we are going to consider what we are going to mainly represented. So what is the thing which we are going to consider, which we are going to mainly takes place? So what is your, so what we want to find out, we want to finding out the value of transient response. So here we are going to consider quite as the total response. In this, what we are going to consider, the total response is nothing but we are going to consider as a two parts, which we are going to call it as the transient response and steady state response. What are two total response which we are going to consider, which we are going to call it as a transient response and steady state response. So what is the transient response and what is meant by steady state response? The transient response is nothing but it is a response which we are going to obtain when the input should be mainly changes from one state to another state. That we are going to call it as a transient response. The steady state response or to show the response of the system whenever the time t should be approaches to infinity. So in this case, the transient response is nothing but it is a part of output of the system when it is going to make it provided to vanish as the time t approaches to infinity. That means whenever the time t should be mainly approaches to infinity, what is your corresponding value of your exponential component? That is e power minus 5 into t, that we are going to find it tends to 0. So that means what the transient response which you are going to consider, that should be mainly given by your sinusoidal component. What the transient response which you are going to consider, that should be mainly given by your sinusoidal component. So therefore, the response which we are going to take in, that we are going to mainly provide. So in this conserved case, what the response which we are going to consider, that we are going to representing as a damped oscillations. The response which we are going to consider, what we are going to mainly obtain, that we are going to representing as your damped oscillations. So which is nothing but called as my C of t. So what is the value which we are going to consider, that according with the help of this, so which we are going to call it as a some 0 to 1 is a steady state value. There we are going to consider, so this should be called as a response of my damped oscillations. Unless we want to go to finding out the value of maximum peak overshoot and as well as called as a peak time. So what is your formula? That is maximum peak overshoot is e power minus zeta pi by root of 1 minus zeta square, and Tp equal to pi by omega d, that is nothing but pi by omega d value is nothing but omega n into root of 1 minus zeta square. We are going to consider to compare with respect to of my form of my closed loop transfer function. So now we want to consider to compare with respect of my standard form of equation, that is, so what is your denominator polynomial? That should be called as the omega n square by x square plus 2 zeta omega n s plus omega n square. So what is your standard form? That is s square plus 2 zeta omega n s plus omega n square. So what is the value which we are going to get? That is s square plus s plus 1. From this we get, on combining the values, that is omega n square is equal to 1, omega n is equal to 1. That should be the mainly radians per second, and 2 zeta omega n is equal to 1. So that is zeta value equal to 1 by 2 omega n. That should be called as a 1 by 2, which is nothing but 0.5. So the damping value we should be arranging called as a 0.5. The system should be called as a underdamped system. Therefore, which we are going to providing called as a damped oscillations. So now we get, that is MP is equal to e power minus zeta pi 0.5 into 5 divided by root of 1 minus 0.5 whole square. That should be called as a 0.165. 3. If we are going to mainly consider what it as a percentage of maximum peak overshoot, multiply with respect of your 100, there we get that is a 16.3%. Okay. Finally, what is your peak time? That is, so what is your peak time which we are going to consider? That is Tp equal to pi by omega d. That should be equal to pi by omega n into root of 1 minus zeta square. That equal to pi by omega n. What is the value of omega n? Value is 1 into root of 1 minus zeta value is 0.5. So that Tp value should be quite as the 3.62 seconds. Okay. So this should be quite as a what is the value of peak overshoot and as well as quite as the peak time for your problem number 8. Okay. So this is the solution which we are going to consider. దీంతో పాటు ఈ ప్రాబ్లంలో ఈ రెండే అడిగారు కానీ మీకు కావాలంటే రైస్ టైం కూడా మీరు ఫైండ్ అవుట్ చేయొచ్చమ్మా. pi minus theta by omega d నుంచి మీరు రైస్ టైం ఫైండ్ అవుట్ చేయొచ్చు. సెట్లింగ్ టైం కూడా మీరు ఫైండ్ అవుట్ చేయొచ్చు. దట్ ఈస్ 40 and 3t for your 2% and 5% error, where t equal to 1 by zeta omega n. దాని నుంచి కూడా మీరు సెట్లింగ్ టైం ఫైండ్ అవుట్ చేయొచ్చు. మీకు ఒకటే గుర్తుంచుకోండి అమ్మా, వన్స్ మీకు జీటా వాల్యూ ఒమేగా ఎన్ వాల్యూ కనుక వస్తే we are going to be able to find out any specification of your time domain. If we are going to get the value of zeta and omega n, from this we are going to be able to find out any type of your time domain specifications for your problems. Okay. So ఇచ్చిన సిస్టమ్ బట్టి మీకు వచ్చిన డాంపింగ్ రేషియో వాల్యూ బట్టి we are going to decide what is the type of your system. ఎందుకంటే మీకు మొత్తం 4 కేసెస్ చెప్పానమ్మా నేను. So there we are going to consider the 4 cases which we are going to take in depending upon the value of your zeta. Zeta equal to 0. Zeta value should be quite as a 0 to 1, 1 and greater than 1. These are the 4 different cases which we are going to be able to find out the response of your second order system. So based upon with the help of my underdamped case, by taking with the help of your underdamped case, there we are going to be able to find out what is your expression for your time domain specification. From this we are going to study what is meant by delay time and what is meant by rise time and what is meant by maximum peak overshoot and what is meant by peak time and what is meant by settling time. So these are the 5 different time domain specifications what we are going to consider for your second order system for the underdamped case. I input is my unit step input. So the underdamped system తీసుకొని సెకండ్ ఆర్డర్ సిస్టమ్ తీసుకొని యూనిట్ స్టెప్ ఇన్పుట్ అయితేనే మీకు ఈ డైరెక్ట్గా ఈ వాల్యూస్లో మీరు సబ్స్టిట్యూట్ చేయగలుగుతారు. సో ఇది అండర్ డాంప్ సిస్టమా కాదని మీరు ఎలా డిసైడ్ చేస్తారు? దట్ we are going to decide based upon with the help of my damping ratio. If the damping ratio should be quite as a 0 to 1, after we are going to calculating the value of C of S by R of S, after we are going to getting the value of C of S by R of S, that value should be compared with respect of your standard form, that is, that we are going to compare with respect of my standard form, that is C of S by R of S is equal to, if we are going to compare with respect of your standard form, that is C of S by R of S is equal to omega n square by S square plus 2 zeta omega ns plus omega n square. When we are going to compare with respect of this particular equation, from this we are going to be able to find out the value of zeta, that is damping ratio value, and we are going to be able to find out the value of omega n, that is the natural frequency of oscillations. From this we are going to be able to find out what is the damped frequency of oscillation, omega d. We get that is omega d is equal to omega n into root of 1 minus zeta square. So ఈ value కనుక substitute చేస్తే omega d లో దాని నుంచి we get the damped frequency of oscillations. మీకు ప్రాబ్లమ్ ని ఎలాగైనా అడగచ్చమ్మా. ఒక్కొక్కసారి కొన్ని స్పెసిఫిక్ గానే అడుగుతాడు, కొన్ని వచ్చేటప్పుడు ఇన్ని స్పెసిఫికేషన్స్ అడగచ్చు. ఒక్కొక్క చోట ఏమో న్యాచురల్ ఫ్రీక్వెన్సీ ఆఫ్ ఆసిలేషన్ ఫైండ్ అవుట్ చేయమంటాడు. Natural frequency of oscillation is nothing but called as the natural frequency of oscillation is nothing but called as omega n. Damped natural frequency of oscillation should be called as omega d. దానికి దీనికి డిఫరెన్స్ అదే అమ్మా. న్యాచురల్ ఫ్రీక్వెన్సీ ఆఫ్ ఆసిలేషన్ అయితే ఒమేగా n అంటారు, డాంప్డ్ నేచురల్ ఫ్రీక్వెన్సీ ఆఫ్ ఆసిలేషన్ అంటే ఒమేగా d అంటారు. ఒమేగా n వచ్చేటప్పటికి డైరెక్ట్ గా మీకు వచ్చిన ఎక్స్ప్రెషన్ లో స్టాండర్డ్ ఫామ్ లో ఒమేగా n వాల్యూ ఏది ఉందో, సో వాట్ ఈస్ ద స్టాండర్డ్ ఫామ్ లో ఒమేగా n వాల్యూ ఏది ఉందో, దట్ వాల్యూ we are going to take n. If we want to find out the damped frequency of oscillation, for that case we are going to apply this formula, that is omega d equal to omega n into root of 1 minus zeta square. So దాన్ని బట్టి we are going to be able to know what is the value of zeta and what is the value of omega n and what is the value of omega d. ఈ త్రీ వాల్యూస్ కనుక మీకు తెలిస్తే, ఈ త్రీ వాల్యూస్ కనుక మీకు తెలిస్తే ఏ ఒక పర్టికులర్ ప్రాబ్లం ఇచ్చినా, ఏ ఒక పర్టికులర్ సిస్టమ్ ఇచ్చినా, సిస్టమ్ వచ్చినా కూడా we are going to able to find out what is your time domain specifications. ఓకే, టైం డొమైన్ స్పెసిఫికేషన్స్ అనేది మీరు ఈజీగా ఫైండ్ అవుట్ చేయగలుగుతారమ్మా ఏ సిస్టమ్ ఇచ్చినా కూడా. ఓకేనా? సో ఫర్ నెక్స్ట్ క్లాస్ I am going to start a unit 4 that should be called as my stability analysis. Okay, in next class I am going to start about the unit 4 on Thursday, that should be called as my stability analysis. అక్కడి నుంచి వచ్చేటప్పటికి టోటల్ గా ఫ్రీక్వెన్సీ డొమైన్ లోకి వెళ్ళిపోతారమ్మా. ఇంతవరకు టైం డొమైన్ లో ఉన్నారు. యూనిట్ 4 నుంచి మీరు మాట్లాడేది మొత్తం ఫ్రీక్వెన్సీ డొమైన్ తో మాట్లాడతారు. That is we are going to call it as the F. Now we are going to talking call it as the T. Now onwards from unit 4 we are going to talking call it as the F, which is nothing but called as a frequency domain. Okay, so the frequency domain also we are going to consider that response which we are going to represent in my S domain only. The value of S that should be mainly replaced by frequency, then the domain should be converted into my frequency domain. Adi elaganedi we can continue in your coming classes. Okay, so with this we are going to complete your unit 3. From Thursday we are going to start your unit 4, that should be called as a frequency domain specifications or frequency domain analysis, and as well as called as my stability analysis. Okay, now with this we are going to closing your today's topic. మా అర్థమైనా మా అందరికీ కూడా ఈ ప్రాబ్లమ్స్?
Yes, sir.
అది టైం డొమైన్ స్పెసిఫికేషన్ ఎలాగ ఫైండ్ అవుట్ చేయాలి, రెస్పాన్స్ అనేది ఎలా ఫైండ్ అవుట్ చేయాలి. మీకు ఏంటంటే మెయిన్ కావాల్సింది పార్షియల్ ఫ్రాక్షన్ ఎక్స్పాన్షన్ అనేది అప్లై చేయండి, కరెక్ట్గా రావాలమ్మా. ఆ పార్షియల్ ఫ్రాక్షన్ అప్లై చేశాక ఆ వాల్యూ సాల్వ్ చేసుకొని ఇన్వర్స్ లాప్లాస్ ట్రాన్స్ఫార్మ్ అప్లై చేస్తే డైరెక్ట్గా మీరు ఏ ఈక్వేషన్ వస్తుందో చూసుకొని దాన్ని బట్టి స్ప్లిట్ చేసుకోవాలి. అక్కడ మీరు కొద్ది కాన్సన్ట్రేషన్గా పెట్టుకొని డైరెక్ట్గా మీ ఫార్ములా వచ్చేస్తుందా, లేకపోతే ఏమన్నా కొద్దిగా మల్టిప్లికేషన్ కానీ ఎడిషన్ కానీ చేయాలా, లేకపోతే మా ఎడిషన్ సబ్ట్రాక్షన్ చేయాలా, మల్టిప్లికేషన్ డివిజన్ చేయాలా అనేది మీకు వచ్చిన వాల్యూ బట్టి డిసైడ్ అవుద్ది. ఓకేనా? సో విత్ దిస్ we are going to complete of your today's class. Okay, Amma? Thank you, Amma. We can leave the class. Thank you.